Hello guys, welcome to the Advanced Look Development for the Enterprise session. So how are you guys doing today? All right, yeah, had a long day, a little bit tired. So if you watch a movie, actually the climax of the movie is at the end, right? So this session is the end of the day session. So this will be the climax of the on-year academy. So I will try to not to let you guys down. I prepared the good things, so let's get started. So today I prepared a practical look development workflow for today. So this is going to be a recipe that you can take and use for your project. So there's going to be some principle, but mostly practical setting and demos. So my name is Min Oh. I'm a technical artist on the enterprise team. I focus on industrial product visualization. So last 3-4 years, I did Epic's GDC demo of Boy and his kite and McLaren 570S car configurator and the human race with the GM Camaro. So if you guys are interested, you can look on the YouTube. You can easily find that GDC demos. And my email address is right there. So after this session, if you guys have any question, feel free to email me, please. So that being said, here is the topic that I'm going to cover today. So from the top, first, a few important points of the physically based rendering, shortened for the PBR. Since this session is going to focus on the practical workflow of the look development, so I will just go over a few rules that you may want to follow when you're working with the PBR. After that, I will talk about what look development is needed, why look development is needed and important. Once that's done, second, we will take a look at what element does look dev scene consist of and going into a bit of each element. So when this element slide is done, we can have 5 minutes of Q&A time for any questions you might have regarding those topics. And next, we will talk about a reference image for the look development. So how important a reference image is and why that reference image is needed. Once that's all done, we will jump into the actual process to how to make a look dev scene in UE4. So I will go over the step first with the slide and then going into the UE4 and show you guys the demo in the engine. So after all the demo is finished, we will have about 20 minutes of the Q&A time for any question about the look dev or any topic from these sessions. So before we jump into our main topic, quickly I would like to cover what kind of problems that I've been hearing from the UE4 users. So first common thing that I hear is many of them is new to the game engine. Second one is making things realistic is hard, always hard. And whenever you learn the new program, there's always a steep learning curve in the beginning. Even if you do something, the end result is too CG or too gamey looking that is not close to what you want it to be, like a realistic look you want, but it's not it doesn't get there. So that being said, I would like to say that there's a few rules before that artistic freedom you can have in on your engine. So today I will cover what makes a game engine different when you're coming from the pre-render environment. Also give you guys key steps that is easy to follow, which makes the visuals too close to realistic. So this is one of our material pack is available on the UE4 marketplace. I will go over that a little bit later. So let's talk about what is a PBR first. So PBR is a physically based rendering. So means that we approximate what light actually does as opposite to approximating what we intuitively think it should do. So that the ending result of working with the PBR is more accurate and typically more natural. So physically rendering based material will work equally well in all lighting environment. So in addition, a PBR does have an intuitive interface because the material value is less complex and interdependent. So even if with different artists, PBR provide a workflow that is consistent and predictable result. So this is another GDC demo I worked on. It's called the human race. I will go over another more samples as we go by. So then we just talk about the PBR. If the PBR is that good, why do we need a look development? So let's talk about what's the look depth first. So definition of the look depth can be vary by industry or project. So for UE4 enterprise case, I would say look depth is literally developing the look of the asset for the project with a correctly balanced lighting environment. So we do the validation of the model and material tweak in the look depth. Addition to that, we also compare the CG model like this with a photograph reference one-to-one to see which part of the engine feature and the engine rendering feature we can improve to make it close to real as much as possible. So then why do we need to look depth instead of just developing the asset anywhere? So because as much as you have a strong look depth in the early stage in your project, materials will behave reliably in all lighting conditions. So as you remember, that's exactly one of the benefit points with PBR. So that being said, PBR requires a physically lighting setup to get the best result. So once the correct look depth is done, your asset will be look good and looks correct and consistent in various lighting environment. So I will go over the good example of the look depth shot from a few Epics projects. So first one is the human race. So this was the collaboration with commercial collaboration with the Mill and the GM. So this is Camaro. And we also wanted to tweak the various material in the same look depth development to get the consistent, realistic look. So this one is metallic silver, car paint version. Of course, we have to make everyone's favorite color yellow, which is, yes, Bumblebee. But disclaimer, this is not UE4 render, but that kind of look is totally doable in the UE4. There's also white version of the car with a stripe option on the top. But not only the various color version of the car, we also looked at the a totally different car model. This is a classic 86 Camaro. So we also make sure that to get the same realistic look of the car in the look depth. This was another car from the GM future car model called the FNR. Also go through the same look depth development process. Let's go to the other project example. So of course, everyone's favorite Star Wars. So this is Captain Phasma from this year, our Epics GDC Star Wars demo. So as you can see, having a various look depth scene will make sure that model will work well in different lighting scenarios. So in this case, left one is a sunny daylight in the park, on the sunny daylight on the park, and the one on the right is the sunny daylight in the rooftop of the building. So once it's that done correctly, so both image looks good and correct. So last example is Andy Serkis demo. Also, this project had a couple of look depth scene to develop the look of the Andy Serkis, so that it has a little bit of the different lighting position and the lighting scenario that we can make sure that the Andy Serkis is look good in any of the lighting environment. So as you can see, look depth process is very important. So that is recommended to have earlier in the production. So today our goal is going to have a neutral daylighting setup that is physically correct as much as possible, and which will give you a good asset look result. So that being said, let's move on to the what element does look depth scene has. So let's go for the look depth scene breakdown. From now on, we'll talk about what element look depth scene has and what that is. Let's go one by one of the element that is in the look depth scene. So first one is the sky dome. which is the visual representation of the lighting scene. So that sky dome visually helps that to see if the model fit into the scene. Also, the sky dome becomes the source of the indirect light. The second one is a skylight, which is an indirect light in UE4. So you can capture the scene into the cube map and make it into the lighting source itself, or you can plug capture your own cube map into the skylight to make your indirect light. So next one is a directional light, which is a blue one. It will be a sunlight. So this will be the main light source of the scene. That should be matched with actual sun's temperature and the intensity. So once all that lighting is set up, we set up the post-process volume. So this will define any of the post-process like color grading, lens effect, bloom, or lens flare, etc. So this volume is where you can starting to have your own artistic choice for the scene. So additionally, you can place this reflection capture probe to define where you want it to get the reflection and add that reflection into the cube map. Finally, you can place your object asset in the scene and starting to develop the look. So as you can see, object is including with the model, material, texture. So you just validate if the model is working correctly, and then you added texture for the material, and then you apply the material into the object if it's working correctly or not. Let's see same element in the engine. So this is a screenshot of the Unreal Engine. So these are the icon of the visual indicator of each element. So from the top one is a directional light, which is a sun. The second one is a skylight, which is an indirect light. Third one is a reflection capture. The last box in the bottom is the post-process volume. Also, all the image that you see is actually sky dome, which is a sphere, big sphere, which will visual indicator of what is surrounding in your environment. So now we know what element is in the look that scene has. So let's talk about a few points of each element. So since this session is focused on the look depth, we will only cover what matters for the look depth and the enterprise specific. So let's start with the material. I will go over a few things keep in mind in UE4. So first one is color, base color. Color is simple enough that you get to choose any color make to your desired material. So there's few things that you want to remember in the PBR. So since there are all the PBR is real world replication with values, which in this case base color is the 3 vectors, which is red, green, blue channels. So each vector goes to the value from 0 to 1. So 0 will be pitch black and 1 will be pitch white, pure white. So in reality, there's no such a thing as a pure pitch black. So same goes to the white. So that as a guidelines, charcoal is the darkest material, which can be value of 0.03. But again, 0.03 is a really dark value. So even if you are making material for some black object, you want it to keep the value higher than 0.3. If your material doesn't get dark enough, that means your lighting environment is wrong. So which has high chance of the overexposed. Same goes to the white. Fresh snow is the most bright, and that covers to the 0.9. So when you do the material tweak, it's easy to falling into the trap that you want it to make any color that you want, but then you have to think about the lighting environment to set up too. So that is why we wanted to have proper look depth scene first, then do the material tweak. Okay, that's the tip of the base color in the PBR, but then give you guys a little bit of a brain break time. So I brought this interesting image. So this is called the building pavilion designed by architect Ashif Khan for the 2018 Winter Olympic. So it looks like a dark universe with the stars, and of course it's just a building with a LED light for the stars. But then this dark material is really dark that gives illusion of the depth that feels like universe. So here's a little bit of close-up. If you can still see it, let me put on the white line on top of it. So that's how the actual building look like. So that black material is called a Venta black. So it's a sprayable material that is observing 90% of the radiation in the visible spectrum. So as you can see in the picture, it's the same face model, but the Vanta black one on the left is you barely see the shape of the face, but then only see the silhouette of it. So that's kind of fun fact about darkest substance material in the world at the moment. So unless your object, a vehicle, aircraft, a building, whatever you're working on is painted with Vanta black, there's no reason to have set use of a zero value of black in PBR. So next is metallic value. So metallic is pretty simple. You just define it as metal or not metal. So which is value of 1 for the metal and 0 for the non-metal. So there's rare exceptional cases. For example, car paint is metal-based, and then you paint it on top of it, and then you have clear coat on top. So when we're looking at it, even if it's metal, it doesn't really calculate it as metal. So you want it to tweak a little bit of metallic value when you make those kind of materials, but just a little bit. So other than those kind of few exceptions, most of the cases you just want to set it metal 1 or non-metal, which is 0. So next is a specular. So specular is just to tell the material how much this material reflects the light. So this, so as you can see, this highlight is what it defines in the specular value. So this goes as simple as 0 to 1. So it's not getting specular error, it's getting specular. Excuse me. So default value is 0.5. So you can easily search for what the specular value of the material you want it to make, and then you can just type that in the value. But default value 0.5 is already a good start. So just one thing to keep in mind is specular doesn't include any color information. So before the PBR era, we didn't have a fancy thing that the real light reflection of the object, and then it reacted to the different lighting scenarios. But in the PBR, and then we had to define what color and how strong reflection is back in the day. But in the PBR, you don't really have to. Base color will drive the color of the material itself, include where specular hit point. So again, but there's always exceptional. So again, for the rare exception, if you really wanted to make different color in the specular, you can break the rule of the PBR a little bit. So this left and right example here is the chroma flare car paint, which has a base color and then different specular color on top of it. So this one, the way we did it is just tell the material when the reflection point meet with the camera, where the camera is looking, then this area will have different color. So also the color information goes to the base color input, not in the specular input. That was a specular. Let's move on to the roughness. So UE4 has metallic roughness PBR workflow, just different than other PBR software use the other material workflow, but UE4 uses metallic and roughness. So roughness is one of the key input that will define the behavior of the material. So every object has its own roughness. So even if you're looking at the clear coat of the car, it looks really smooth, but if you're looking closely and then you put the light on it, you will starting to see the scratch, or you're starting to see even the orange peel, which is the bump of the clear coat. So let's look at the simple drawing to make sure you guys know. So just make it easier, this drawing is very extreme comparison. So right image is just a really smooth surface, like zero roughness. The left image has a lot of rough. So let's think about some object you're really looking at with a microscope on it. So right, clean surface, lighting heat, and then it lights bounce, and then it goes reflection. Reflection goes pretty much the same direction. So you can get the single reflection look. So you can get the very clear look of the reflection on your material. Left one, roughness, very object with a very rough surface on it. Light comes in, light bounces around in the rough surface of the object. Also, some of the object is observing the light, and then light goes through, and then it just travels inside of the object, and then finally it comes out. But then, as a result, this reflection light goes everywhere, so we see the less reflection, or it's just going to be like very dull looking. So here's the fun fact about the roughness. So this person, Asu Aster, one day I guess he has nothing to do at home, so he just like brought the aluminum foil from the kitchen and then trying to make a bowl, and then starting to sandpaper it until the end of the day, I guess. So one on the left is what we usually see with the aluminum foil. So right one is the one that he really sandpaper it hours and hours. That makes aluminum foil to almost look like a chrome sphere. So as you can see, left one has obvious roughness that on the material, that reflection is breaking up everywhere. But right one is relatively smoother than left one, so which break less light. So we can see the clear reflection hit on the same aluminum foil. Okay, we talk about the PBR materials. Let's recap of the PBR material really quickly. So color, you want to use a physically plausible range. Metallic, you just said metal or no metal, except exceptional case. Specular, there's no color information. You want to drive your color with the base color. And roughness, rough is matte, smooth is shiny. That's the PBR material point that you all need to remember. So let's look at a few examples of the good material looking. So we will take a look at the carbon fiber, car paint, and car reflector in the UE4. Start with the carbon fiber. As you guys know, carbon fiber is actually fiber is that weaved together is on the bottom. So we put that weaved fiber bottom, and then we put the clear coat on top of it. So as a result, we can have this beautiful carbon fiber. You can see all the fiber underneath, but then you can see the also clear coat, and then you can feel the depth of the in between the carbon fiber and then clear coat on top. So next one is car paint. Car paint, you have, like I said earlier, you have metal, and then you colored with your base color, whatever you color want, in this case blue. And then you want to have a little bit of flake, so you put the flake paint. And then to protect your car paint, you put a clear coat on top of it. So that will make this beautiful car paint. So as you can see, usually if you're looking at the car, it depends on what kind of car, what kind of car paint they use. But then usually the flake of the car paint is, you can only see where the lighting is hitting. So we kind of worked hard to get those kind of material looking, and then we do have this beautiful car paint. Next one is the car reflector. So it's simply reflector pattern we wanted to have, and then you wanted to put the plastic cover on top of it, which makes a car reflector. So just like a little bit of difference with the other clear coat or the car paint of the clear coat or the carbon fiber. Since this is a plastic cover, the cover itself is a little bit more rough, that will have less reflection, so that feels like more plasticky. So these all the material that I just talked about, including the other awesome material, is available at the UE4 marketplace called the Automotive Material Packs. So you can just download it free, and then you can use it for any of UE4 project. Also, you can just open it up, and then you can just trying to reverse engineer how the material has been made. So that was the material. So let's move on to the lighting. So for the lighting, I will cover types of the light that UE4 has, and then mobility, which defines the way light works with the impact of the performance. That will be one of the biggest different element when we compare the real-time lighting versus pre-render lighting. So start with the lighting type. UE4 has these 4 types of light. So first one, directional light, which is the light infinitely with a defined angle. Second one is a spotlight, which is cone-shaped light that has the inner and outer cone angle settings. Third one is point light, which you can think it as a light bulb, so that lit 360 degrees all around. So these are three light types, are pretty common type of light you can find in the pre-render software too, NECG software. But the last one, skylight, is the real-time optimized way of the indirect bounce lighting for the whole scene. So simply, you can think it as sky of the world. This sky use the cube map, which you can capture from the scene or plug your own cube map to light the scene with the skylight. Next is light mobility. So you can see there's three mobility mode in the static, stationary, and movable. So simply, static and stationary is pre-calculated the lighting information into the light map texture to run performance efficiently. So the difference between the static and the stationary, stationary has a bit of more dynamic settings that you can change on the runtime. So such as like brightness of the light, color temperature of the light, you can change it on the runtime. Meanwhile, one on the right, movable light is fully dynamic. That is most expensive. Everything gets calculated in real time, but the movable light can be changed. But at the same time, the good thing about the movable light is you can change anything during the runtime. So you can move around, you can just change the position, rotation, or also as well as you can change the intensity or color temperature, etc. So since the static and the stationary light has to be baked into the light map, all the object that is set to static or stationary will need light map UVs. So I would recommend to use a movable light, not to have too much headache for the light map, also take a maximum advantage of the real-time engine. You just have to remember the cost of it and then think ahead, like what kind of thing will be moved, what kind of thing will be not moved to set to static, stationary, or movable. Okay, that was the lighting. So let's move to the post-process. So like I mentioned earlier, post-process is all the effect that you wanted to have on top of the other settings of the scene. So I will not go over every setting in the post-process, but only the important one for the look depth, which is bloom and the exposure. So the basic goal of the look depth scene is for today is that we wanted to get the most neutral setup for the scene. So that way we can evaluate the look of the asset without any contamination. So first one is bloom. So this usually can add it later, but also have to see how much material reflection is react with the material. So last year with the human race demo, that GM Camaro demo, we implemented the new method of the bloom called convolution. So this bloom gives much more believable optical visuals. So we used a pinhole to capture high dynamic range corner flare, what you see in the screen, so which is included in the UE4 as a default. So you can use it anytime. So next one is exposure. Actually, one of the things I would like to emphasize is that this PBR world, it is trying to replicate real life behavior. That is including camera and the lens. So it will work as intended if we think UE4 as a real life camera or lens. So this exposure triangle is that applied to the rear camera and rear camera photography, so as UE4. So since the goal of our look depth scene is again for the neutral light, so that we wanted to have not overexposed, meaning dark, meaning the bright, neither underexposed, meaning dark. So with the post process, we can simply set the exposure value to 0 to make the look neutral. So last of the look depth element, I would like to point out the two settings in the mesh in UE4, so especially for the enterprise purpose. So there's two settings. First one is high precision tangent normal, and then second one is high precision UVs. So as a real-time engine, generally UE4 compresses the mesh information without losing too much details. But now we're starting to have a super sharp reflection that is critical to enterprise use. So we need more precision in mesh data. So if you turn on this high precision tangent normal, you will see much more clear reflection on the mesh. So as you see on this picture, so left is high precision normal is turned off, and the right side is high precision tangent normal is turned on. So you can see the reflection is much sharper on with option on. Also, the high precision UV will help you to render texture without any artifact. So that was all about the element of the look depth. So we would like to have 5 minutes of the 1 or 2 questions if you guys have any.
Yeah, regarding that last part of the high precision tangent.
Yes.
Let's say that I got a chrome material, and in order to import the geometry, I make a couple of concessions regarding the tessellation, and I have much more like a coarse geometry.
Okay.
Because to decrease my poly count. If I have high precision, is it the chrome material is going to show me more how that mesh is fractured, is not following the original mesh data? So it will be to my best interest not activate that, because it will show me how my tessellation settings are below. Is that correct? Is that a correct
So
assumption?
to repeat the question, to make sure that even no matter what, how dense the poly count is for the mesh, if you have a high precision normal is turned on, you're gonna see the more reflection. In general, yes, but at the same time, it also depends on the mesh poly count. So more mesh poly count you have, the surface will be much more clean, and looks curvature will be more correctly. So I would recommend have enough poly, not go over, not go under, but then you want it to have enough poly. So on your engine can handle like pretty high poly meshes in the real time. So I think you have a many freedom to have a different tessellation option. So high precision normal option will be also affecting by a poly count too. That's my answer, yes. Anybody else? Please.
I have a question.
Yes, please.
Do you know if Unreal plan in the future use BRDF for, you can get 2 reflectometers. Some software use that for very, very high quality reflections.
Right. So question to just make sure to repeat, do you have any plan for the BRDF that you can really actually capture the material and then you can have that in the UE4?
Exactly.
The answer is yes. We have a plan to use some of the companies' light capture product that you place the sample of the material, and then it will correctly convert the value into the UE4, and then you will have a base color. It's how value it is, and the roughness, and the specular. So we do have a plan for the having those kind of pipeline.
What company you'll be interfacing?
We have a few of the companies that we're still talking about. So I think
our company use BRDF, but they are very specific for one software. It does not connect to other software.
Yeah, I think that's one of the things about the in between different rendering softwares, because different rendering software uses sometimes different shading model, or the rendering algorithm is different. But then, so as a UE4, that we kind of want to make a standardized workflow that material can be crossover one to the other program. So at the moment, I cannot really name the program, but then we have a plan to make a kind of a standardized material that can be coming over from Max, Maya, or to the UE4, that you can have the same result or even better looking.
What version will be available this?
I'm sorry?
Do you know what version?
What version of the engine?
Yeah.
In near future soon. Very near, yeah. Anybody else, please? Oh, okay, yes, please.
I guess I'll just throw in, I tend to use a lot of substances, and I realized that not much is being mentioned on the use of Substance Painter and Substance Designer that kind of does some of this for us, where you have a unified material that goes from Maya to Max to Unreal, then having to go from Maya then recreate all of my textures again with the Unreal's materials. So I just wondered, what are you guys' plans, or if that's anything that you guys do, or is that just somebody else's software? And
actually, that is a kind of related to the prior person's question. So question was that he's using the Substance, but the Substance will kind of provide that the workflow of the standardized material that can use be a different program or a different renderer. So UE4 is very collaborated with the Substance. Actually, UE4 has a plugin that you can just loading the Substance material and then they can use. And then Substance also has same UE4 rendering, the algorithm that can be previewed in the Substance that can bring over to the UE4. So our answer, my answer would be the Substance. In the Substance case, yes, it does porting over one to one, close to the one-to-one. And then, like I said earlier, we wanted to make a standardized material of file format that can be traversed across all the platforms or all the programs. Is that answer your question?
I guess the main thing was I did the class earlier, which was about creating materials and PBR materials, but I didn't see anything about Substance. So
Okay, yeah.
Basically that workflow isn't being mentioned.
Okay.
And we do have the plugins, and I know that on the M&E side, a lot of those are already using that.
Okay.
It makes it very easy to modify and change
Yes.
instead of having to restart.
Right.
I know that on the automotive and aerospace side, they might not have the same experience with the tool sets that those of us coming from an M&E background have.
Right.
So we would just hey, we're using Substances, we already have our library, why the heck recreate this whole wheel?
Right.
Let's just plug these in and let's go for it.
Yes.
And, they're already tried and true, and I was just wondering, I didn't see anything of that so far, but it's
Okay,
the
yeah.
end of the day, so.
Well, I guess in the context of the Unreal Academy, we kind of wanted to focus on the Unreal Engine, but then we do use the Substance a lot in our workflow too. So I would say that could be a choice, your choice of workflow that depends on the project, depends on the company, what package that you want to go with. So Substance is definitely one of the good workflow that you can use the standardized material that you can have same look into one to another program. So I agreed with you, but at the same time, like I said, we do have a standardized material that coming up, yeah. All right, so we had a quick Q&A session. Let's starting to talking about how to set up the look depth scene in the UE4. So to remind you, our goal of the look depth scene today is neutral lighting, sunlight, and at midday. So in general, you wanted to set up the look depth scene the most relevant to your final scene. So this screen will be the final result of what we will see after the demo. So as you can see on the top, that's a reference image that taken by a camera, which is photo. CG sphere, bottom the two sphere is a CG version, a computer graphics version in the UE4. So we're trying to get the reference image in, and then we're trying to make the same look in the UE4 to replicate the same lighting, same lighting scenario in UE4. So one of the most important thing about that I always keep in mind is reference. If we want to make the scene close to realistic, then we should have enough information to replicate that look in the UE4. So of course, there's the internet. You might can search you on the reference image, but internet images are always highly compressed because of the internet. Needed to be file size need to be lighter, and sometimes the images are photoshopped. So you cannot just trust what's real, what's not. So even if it's same red color, if it's correct red color or not, you cannot just trust it. So I would, personally, I would love to take like reference by myself that I can trust. So then what reference image you need for the look development? So first one is gray ball, second one is chrome ball, and third one is panorama high dynamic range image, and fourth one, the last one is color checker. I will go over each one of these and then see why it needs and how we can capture well. So first one is gray ball. So this gray ball image will tell us what direction the sunlight is coming from. Also looking at the shadow fall off of the surface to match the intensity of the sunlight. So one of the tricks I learned from my lead, you gently narrow your eyes that you can have like kind of blur filter on your eyes. Then you can see shadow fall off in better to just like, avoiding other factor. So you can just like really judge how the shadow fall off looks like. Yes. So this half gray value is photography standard. So which is in linear color space is called the 18% gray. So also more the diffuse the ball gets, the lighting information will be close to accurate. So we use the custom made from the company called the Lab Sphere, which is 90% diffused. Second one is chrome ball. With the chrome ball, we can see the sun position, so which we can clearly see on the picture. Also, chrome ball will help to see sky dome orientation, which is the actually reflection environment you see on the image. It will be a cube map in the engine that is representation of the surrounded environment. Also, you can reference the intensity of the skylight, just looking at the image. Also, the chrome ball looks super smooth, but this chrome ball is also actually has a really tiny roughness on top of the ball, top of the ball's surface. That doesn't make ball 100% reflective. So you can measure the reflectance of the chrome ball by taking a picture ball against 18% gray card, which is a mid-gray. So that when you measure that gray value in the ball here, you can get the offset values to match more close to the ball's reflectiveness. Next reference image you need is to have this panorama high dynamic range image that captures 360 degrees all surrounding environment. This will use it for the sky dome, which is the visual representation in UE4. So as well as it's going to be source of the indirect light. This panorama image is highly recommended to capture as high dynamic range image that will have most exposure value data in the image. So as you can see, one on the left with a red arrow, so that's the darkest underexposed image that we could capture this sun's data of the sun. But also, red arrow on the right image, this is overexposed setting that can capture all the information even in the shadow lighting. So to capture the panorama, fisheye lens is a camera with a tripod can be used. For our case, we use the motorized device called a round shot VR device. So you can program this device to what exposure bracket that you want it to take a picture, and then what angle that you want it to get the full panorama image. So for our purpose, we need a 360 degree image. So it goes 180 degrees, and then it goes up and down to take a picture with the fisheye lens. So last reference image is color checker. So this is photography standard Macbeth color checker. So we can take all the reference picture with this color checker in the frame to get the white balance of the image. So that way we can get a trustful reference image. I will go over about the color checker later on into the little bit of more details. So these are the main equipment we use for to capture the reference image. So just a simple list, you can get the idea. what might need to be captured, the reference. So from the top, there's camera, a 5D Mark III we used. We used the various lens, and then also fisheye lens. We used the Sigma 8mm, and round shot VR drive for the motorized HDR capture one. So and then many other accessories, like just common thing from the when you do the photography. You need tripod, you need to like many batteries, etc. So now we know what reference we need, and then we are ready to set up in the scene in the UE4. So let's take a look at each steps and what to look for. Start with the sky dome, which is visual indicate indirect light source. Second one is a directional light for the sunlight. Third one, skylight for the indirect light. The last one is post-process volume. So when the setup is done, we can check a sunlight to shadow lighting ratio check to make sure that lighting setup is correctly done. Also, we can check a white balance with the color checker. Once that check is all done, we can starting to drop the asset in the scene and then starting to do the look depth. So let's move on to the first step. First one is sky dome. Sky dome representing the surrounding visuals. So we wanted to use this, a sphere static mesh that can display and give the data from the 360 or around. Simply, you can think it as Earth. There's a few settings. First, we need to have the inverted normal direction mesh, which we're facing inward so that we can see the face of the mesh. Second, we want to set up the as unlit material. No lighting or shadow will be casted by this sky dome. Last, you want to plug in high dynamic range image, which will have a full range of the image that we can take advantage of the multi-exposure. Next one is directional light from the, for the sun. So this setup is simple. So you just angle it to match the sunlight from the reference photo. For the intensity, 3.14 pi would be a good start point. The pi value is actually kind of side effect from our algorithm, and then it's pretty common value across the pre-renders too. And the last one, mean roughness is the way to blow out or highlight that is you feel is too sharp. So generally, it is a good idea to use the roughness in the material, but rather than setting on the mean roughness on the light, but it can be useful for the occasional straight light that has sharp of the highlight. So mean roughness value, low the value is going to be sharpen the highlight, higher the value is going to be soften the sharp light, soften the highlight. Once that's done, you want to set the color temperature for your sunlight. So in UE4, you can set up the color temperature from the 1700 Kelvin to the 12,000 Kelvin. Sunlight at midday is around 5500 Kelvin, depends on the where you capture. That could be a good start point for the sun color temperature. Now we need indirect light from the skylight. Skylight setup is simple too. You just drop the skylight actor and keep the default value of intensity of 1. Once all the lighting setup is set up, now we need a post-process. As a default, it comes in post-process drop. Few option is turned on. So since we wanted to make the neutral lighting setup, we want to make this setup, all this setup setting disabled in the post-process volume. So after done with the post-process, it is time to check all the setup is correctly done. So that way we can trust, we can really trust the lighting to the look depth. One of the way to check we can do is sunlight to the shadow ratio check. The way you do is you can measure with this kind of light meter, measure the sun value of sun exposure value to the shadow exposure value. And then from the depth value, you do the simple calculation. So some exposure value minus shadow exposure value, then you will get the value of the difference. That difference value would be the sun value for the ratio to the shadow. So for example, the one on the fourth paragraph is the measurement that I was getting from the one of the capture process. So sun value was 15 exposure value, 15 eV, and the shadow was 13 eV. So 15 to minus to 13 is 2. So 2 to the 2 is 4. So that became sun to shadow ratio will be 4 to 1. It's kind of like numbering, thinking in the head right now, but then I will show, when I go to the demo, I will show how to actually check this kind of ratio in the engine. So we all went over the slide about the reference picture for the look depth and the steps for the look depth setup. So now I will jump into the UE4 and show you the recipe you can take and then use it for your project. And once all this demo is done, we will come back to the slide and then recap all the setting I did, and then you can remember things. Okay, so let's jump onto the UE4. So this is the Unreal Engine. So this will be the kind of final look that you want to have when the look depth scene is done, and then this is like kind of a sample asset that I brought in. So first one is this Camaro. It was from the human race demo, and second one, this McLaren is from the 2016 our Epic GDC demo. So I will go over step by step how to make this scene look depth environment in the UE4. So let's just start from the scratch. You go to File and New Level, and then make it empty level. So just before I go over, let me quickly make a quick adjustment in here, and then explain what is each element, which window is. So from the excuse me. Okay, I'm just going to do this way. Okay, so from the left side window is called the mode window. Let me actually quickly make this one a little bit bigger that you can see better. A little bit better, but it's squeezed. Photo just explain this window one by one. This left one is mode that it has like made actors in the engine that you get to choose. You get to choose and then use it from cube, sphere, cylinder. There's lighting. There's a cinematic actors. There's a post-process volume is living in the visual effect tab. So you can quickly looking at it. Also, you can search just name of it to use any actor that exists in the mode window. And this main window that you see is a viewport that this is basically what you're gonna have at the end as a end result. On the bottom, there's a content browser, same as just a window explorer. You just like save the any asset, and then it's gonna be living inside. That you can check, you can search by the name, or you can have all the asset that you have. One of the tips that I'm using a lot is that if you go to the content browser, right bottom, there's a view option. You click it, and then you can see there's a menu called the show engine content. You click that on, and then you can see the engine content was created in the content browser. So there's some of the content that is being created in the engine is not in the mode, but then you can also use it in here. So there's many useful asset is already exist. That's the kind of tip that you guys want to try it out later. On the right, all the way to the right, world outliner. This is simply whatever the asset that you put it in the scene is going to be listed, and then you can have folder. You can make it organized. And then details view window. Whenever you click this asset in the world outliner, it's going to show all the setting that you need in the details window. So let's, once that's done, let's go back to normal view. I'm going to try my best to go slow as much as possible to make sure that you guys are following and understand. If I happen to be go fast, please gently raise a hand and just yelling at me, okay? Okay, first back to the slide quickly. So we're gonna start with the sky dome, which is a visual representation, and then a source of the indirect light. For the sky dome, we wanted to have a sphere. So you wanted to bring the sphere in to the engine, just a drag and drop. And as you can see, sphere is in the world outliner, and then you can, once the sphere is clicked, you can see all the details. So for the organized reason, let's name it as a sky dome. So now we have a sky dome. So what I wanted to do is reset the location. So if you look at this transform window view, there's yellow arrow that you can reset. Once you press it, this sphere will be the center of the world that is positioned in the middle. If you remember correctly, this sphere mesh has to be used with the inverted normal one. Conveniently, our engine has inverse normal sphere, so you can just type inverse. So you just go to static mesh, static mesh, and then click this arrow, and then it will pop up this window. So, and then you can type the any asset that you want it to looking for. When I type the inverse, sphere inverse normal exists, so I just click that, and then this sphere now has inverted direction that will facing inward. Once that is done, you want it to make it big as much as depends on how big is your scene. In my case, I would like to make 1,000. So I made my Earth in here. For the sake of the demo, I would like to put my sample mesh here. I go to content browser. I already downloaded automotive material pack from the marketplace. You just type the sample mesh, sample, excuse me, preview mesh, yes. And I'm just gonna quickly make copy of it, and then the way that you put it into the scene, you just drag and drop into the scene, and then again you go to transform location, and then looking at this yellow button, click the yellow button, it will be center of the world. So now we have the sample ball in the center of the world. So let's make it to rotate that we can. It is looking at the camera, and I'm gonna quickly apply the material from the automotive material pack, which is carbon fiber. You just click the material icon and then go to the material element that you want it to add, and then you put the you apply the material. As you can see, I'm pressing G key right now. So G key is a shortcut for the hiding and unhiding the all the icons, indicator of the when you're working for the you're looking at this what icon you have for your tool set. So when I press the G key, as you can see, there's no lighting information, there's no sky dome texture, so you see the black part. So from now on, let's starting to make the bring the assets. So I'm gonna make a new folder called Look Dev Demo. Today is right now it's 5 o'clock, so let's make it 05. You go in there, you press a right click, and one on the third top, there's import menu. You click that, and going to the place where you stored your assets. So in my case, I stored my asset in here. So one that you wanted to bring it first, for the sky dome, you wanted to bring the sky texture. So one on the bottom, I have a sky texture ready. You just import it. It takes a little bit of time. Texture came in, and then I'm checking. It looks great. So I'm just gonna save it. And close it. I really like things to get organized, so I would like to make another folder inside subfolder that we'll call the sky, and then whatever the related asset will be in this sky folder. It's going to take a little bit of time. So once that's done, we have a texture. So now you need a material that will that will apply this texture into the material. Then material we can apply to the sky dome mesh that can display the sky. So let's make a material. So the way you do it is from the content browser, you right click, and then you can see all the basic asset type that you can make. You go to the material, which is the third one from the basic asset menu. You click it, it will show up a new material. I'm gonna name it as M_M as material. This is kind of a UE4 standard name convention that you can just search on the web, UE4 name convention, it will pop up. So M_sky, so material of the sky. Simple it is. So when I made it, if you double click it, this material editor window will pop up. So if you remember earlier, when I talk about the sky dome, you wanted to make unlit material that this sky dome doesn't get any lighting or shadow information. So the way you do it is that you click this node graph here, the main node graph, and then you go to this left window, and then from the material tab, under material tab, there's one called shading model. Click it, and then one on the top called unlit. So that's the shading model that you want to have for the sky dome. You click it, and then you can see the main this material node is only available, only this emissive and the multi-position offset, pixel depth offset is enabled. So emissive color is the where you want it to plug your texture on. So the way you do it is, you can simply just click the texture from the content browser we just imported in, and you just drag and drop in here. And this texture sample node will be created. So you can see from the top, this will be texture sample. And then this bottom fourth tab is that where you can use only the red channel, green channel, blue channel, or alpha channel. But in this case, we want you to use all channels. So you just click this circle and then drag and drop into the emissive color that we want it to plug into. So now once you drop it, now you can see that this material was created. So I'm happy with this. So you go to on the top, and there's apply button. So that will compile this material, and then you can save it. Once that's done, you go back to the viewport, or you can go to the world outliner. You can find your sky dome, which we renamed it together. So you press this and go to the content browser. There's material for the sky. You click that. And if you go to the detail window, in the material tab, there's element 0. With this arrow button click, you will apply this material. So now we have this sky dome with applied texture applied. That the texture we imported with the material is applied into the mesh. So if I go far, so this is a scale of the 1,000 of the sphere that you see from outside. So that's how big that the sky dome is. And then I'm just gonna click my preview asset here, and then press the F key to focus. That we can come back to the middle of the center of the world. So now let me press the G key again. So G key is hiding and unhide the engine toolset indicator. So when I unhide it, as you can see, this sphere gets black. The reason why is, of course, we don't have any light in this scene at the moment. So what we wanted to do, let me quickly go back to slide. So we just created a sky dome, which is visual. Now we wanted to create this skylight, which is indirect light. Let's go back to the engine. So the way you do it is that you go to mode window on the left side, and there's light tab. and there's the skylight. Also, you can just type in here to find the skylight by type the sky. You just click, drag and drop into the scene, and then we can make this again the location tab. Press the yellow button to bring this skylight into the middle, and then bring it up that we can see a little bit better. So right now, skylight is in, and we're starting to see some lighting, but we still don't see the light. It's black. So the reason why is that skylight has this option. Skylight has this option. One of the details window, where my mouse cursor is that sky distance threshold. So it will define how big the skylight is going to be and how much that by the distance it will capture all the information from there, and then it will make the cube map that makes indirect light. So in this case, our sphere is smaller than our skylight. So I'm going to make 10,001. Once I type that in, as you can see, we can starting to see the lighting. So let me just get close. So another option that I wanted to talk about in the skylight is a cube map resolution. So as a default, it is set to 128. So cube map is just like think about the cube, which has a 6 side. So each side, this will define how much resolution each side of the texture will get. So right now it is set to 128, which is pretty low, which is good optimized. Maximum you can use 1024. So it is 1024 per each cube side. So it has a 6 side of the 1024 cube map, so which is like huge. So it will create a much better crispy reflection around. Once that's done, let's go back to the slide to remember the steps. So we did create the sky dome with the sphere, and we just created the skylight with the skylight actor. So right now, this blue one, directional light, which for the sun, this will be the step that we wanted to create. So let's go back to the engine. Again, the way to choose the directional light is go to the mode window, go to the light tab, and then there's directional light. Drag and pick up and drag and drop, and then set it to the default middle of the scene. And this icon here that I'm clicking will change your gizmo to orbit is local or world. So I'm just going to make it world and then bring it on the top. As you know, the directional light doesn't get affected by position, so you can just place it anywhere. I'm just going to place it that we can see better. Also, once that lighting is set up, as you see on the left top of the this viewport, they set some something with a red. So it's called lighting need to rebuild. So meaning that once this sunlight came in, that engine is asking, oh, you have a stationary light that is set to. You have light that is set to stationary, so you have to back the lighting. Otherwise, you're not going to see final result. But then, as I suggested, for the enterprise uses, you might just want to use a movable. So that red message will be gone, and then this directional light right now is fully dynamic that calculated in the real time. So for the sun directional light setting, let's quickly rename it in here as sunlight. That way we can have much better organized. Click the sunlight. Let's go the setting that is important. So for the intensity, as I showed you guys earlier in the slide, we wanted to use the value of the pi, which is the 3.14. The reason why is, again, that it's a side effect of our algorithm, and then it's kind of like common value that you can start to using. So this is a like start point. Once you set up the intensity, you want to set a color temperature for this sun. The way you do it is you go to the lighting tab, and then you go to there's a menu called the use temperature. You click that on, and this temperature menu will enable it. So you just go there, click it, and then you just type the 5500, which was the color temperature for the midday sunlight. Once that's done, I think I'm happy with the look at the moment. So let's quickly go back to the slide. So we do have sky dome, which is a sphere, skylight, which is indirect. We just added a directional light, which is a sunlight. So now it's time to add post-process volume, which is this velvet color. Going back to here, the way the post-process volume is, again, go to the mode window. You can go to visual effect tab, and post-process volume is on the top. So you just drag and drop. And then again, go to the transform location. You see the yellow arrow. You just click it. And excuse me, post-process volume. It's going to be center of the world again. Post-process volume, as you can see, this is a size of look of the cube. So actually, that volume means that whatever the object or scene inside of this cube area will affect it by this post-process setting you set to. But at the same time, we do have this other option. If you go to the post-process volume details window, go on the bottom, there's a post-process volume setting tab, and there's checkbox you can check. It's called infinity extent, which is unbound. If you click that, it will just ignore the size of the volume itself, but then it's gonna just apply the post-process for the whole scene, which comes in handy. So now, as I keep emphasizing, we wanted to make a neutral lighting looking, not overexposed, not underexposed, so that we wanted to disable every setting that is in the post-process for now. So color grading film, mobile tone mapper, as a default, it looks neutral, so we just don't want to touch it. Going to the lens tab, chromatic aberration, it is set to 0, so which means it's disabled. Bloom tab, there's method. You can click the method and then you can change it to convolution. So this bloom can be set later, but I personally like to put it in from the start that we can see the reflection hit much better. Quickly, let me show you what I mean by bloom. So right now, this is carbon fiber. Since we have a sunlight, which is directional light, so we can see this specular heat that is happening in our carbon fiber material. Post-process volume, if we do the standard old version of the bloom, which will look less interesting, but if we use the convolution way, it looks much more interesting. That has like a flare, corner flare looking. But in general, convolution method is a little bit more expensive, much more expensive. So you wanted to think about your budget for the scene. So once that's done, you wanted to go to the camera. There's a bottom one, exposure compensation. So that will decide. It will darken or brighten the exposure of your scene that you can see. So this is the way that I was talking about. The camera exposure setting is in here. Once that is done, we also have exposure menu. So second and third one is called the min brightness and max brightness. This was originally set up for the eye adaptation, which is let's say, you are looking at the scene, you are in some kind of room which we need a little bit of like underexposed that we can see better. Overexposed, we can see better because there's not so many lighting in the room. But then if you go out, if you inside the UV, if you go out, you can have sunlight, which is really bright. So you kind of want it to have underexposed. So that's that min max brightness is having those kind of eye adaptation setting. But in our case, we just want to have a neutral setup, so I'm going to set it 1:1. So right away, you can see the brightness for this scene is looks correctly. Let's go back to post-process volume. Lens flare, we don't want to have a lens flare at the moment, so set to 0 in the intensity. Image effect, the vignetting, set to 0. Grain, set to 0. Depth of field is already disabled. And next step, rendering features. You go to ambient occlusion, and this from top 2 is already disabled. Ambient occlusion, you want it to disable it for now, and global illumination is not applied. Motion blur, you want it to disable it. Set to 0. And light propagation volume is disabled. Screen space reflection, we want it to disable it for now. So all the setting I just did is going to be recapped in the end of the slide. So if you are missing one or two settings, just don't worry about it. I will go over again. So once that's done, we just did post-process volume placed in the world, and then we just disabled all the lens effects from the camera that we can see the neutral lighting scenario. So let's go back to scene. So we did set up the sky dome, which was the sphere, skylight, which was the just actor that creates indirect light. We set up the indirectional light, which is sunlight, and we just dropped the post-process volume to make it scene neutral. And we did have object placed already, so we are looking good now. So next, this is going to be a look depth setup that we wanted to have. As you can see, top one is a reference image, and bottom one is a CG sphere. So let's starting to create that reference image and the CG sphere in our engine. So start from the top one, the reference image. So the way you want it to do is I would like to make another folder called reference image to make it things organized. You're going in, and then you want it to import that reference image that you can use. So the way you do it is you right click, import menu again, and as you can see, there's a chrome ball and gray ball image that is ready. So you want it to import that. Once the import is done, you can check, double click it, looks good. Gray ball looks good. So now we imported two texture for the reference image that we can use. So same as a sky, we need a material that can apply to the mesh. So simply what I'm gonna do is gonna make a material. So M as a material, underbar is gonna be master material for the reference image. So I'm just gonna call master material, master reference image material. So once it's done, double click, it will open up the material editor. So in here, same as a sky dome, this is only the reference image, so we don't want to get any lighting or shadow information. So same shading model we're going to use, which is unlit. So the way you do, if you remember, you click this main graph node and then go to the left window, and there's material shading mode. You click that and then go to the unlit mode, and then it will create emissive color available only. Again, the way you to apply the texture, you go to the content browser in here, and you drag and drop one texture, drop it, and you connect this thing to the emissive color. Let me quickly change this to. There's in the preview material preview. There's a few of the mesh is ready that you can evaluate the mesh. You can evaluate the material that you are working on. So right now, once you plug in, I think it looks good. But we need a two reference image material. So the way I'm gonna do it, this will be my master material, but we want to have material instance that can create gray ball material and then chrome ball material. The way you do it is in the top of the texture sample node, you right click, and on top of the third menu is called the convert to the parameter. You click it, it will change it to parameter, a parameterable node. And then it is waiting to me to type the name of it. So I'm just gonna type reference image, just shorten it. Once that's done, I'm happy with it. You go to left tab, apply to compile and save. Once that is done, so we do have a material master reference image that we can use. So let's create a material instance for each chrome ball and gray ball. The way you do it is right click on the master material, and one on the top, you see create material instance. You can click that, and I'm gonna type MI, which is material instance. Again, this is a UE4 name convention you can find on the web. And then I'm gonna name reference image chrome ball, chrome. And you double click it and check. And as you can see, material instance, whatever the parameter that you parameterized in the material, you can see in here. You just simply check the checkbox with the name that you just made, and then you can add it. You can change the texture or the value that you just put it in the material. In this case, this is for the chrome ball, but we already applied the chrome ball texture in here, so it's looking good. I'm just gonna save. And then I'm just gonna duplicate this one to make the reference image for the gray ball, which is mi underbar reference image gray. Double click it, and it's still looking chrome ball. So what I wanted to apply here, this gray ball texture that we imported together. So you click the gray ball and you go to this parameter setting, make sure this checkbox is clicked, and then go to this arrow, you click it, and then it will apply. And this one looks good, and then I will close this. So now we have these two selected material instance that we can use. We can apply to the mesh, then we can review in the scene. So in the scene, so as you can see, this is like just a simple mesh, plain mesh that is just displaying two reference image. So that means we need plain meshes. So the way you do it is go to the mode, basic, and you can find the plane here. You just drag and drop and then make it center of the world again. And then let's make it select going up, and let's make it face to the camera that we can see it better. And we're gonna make two of them, so make it a little bit space here. And I personally would like to type the exact number, exact value that we can make organized scene. And then we need one more thing. And another tip of the making duplicated mesh or asset in the UE4 is you click Alt key and click the arrow and then drag and drop. And then you can make a copy of this plane mesh. And then this mesh was set it to the y-axis to 60. I'm just gonna make opposite or minus 60, so we can have two plane mesh ready. So this for the two plane mesh, as you can see, is in the place in the world outliner. I'm just gonna name it one by one. Reference image, SM, which is a static mesh. Reference image, reference. This will be gray ball, gray. So the other one, I'm just gonna name it SM underbar reference chrome ball. Okay, we have two mesh ready that we can apply this material instance we just created. So the way you do it is gray, click the material instance you want it to apply, and then click the mesh you want it to apply to, and then go to the details, which is material tab, and go click this arrow button. Boom. The texture is applied, but orientation is wrong. This is because of the plane mesh is UV is not match with the texture that we have. Simply, we're just gonna rotate, make it correct, and we want to do the same thing for the chrome ball. So reference image chrome, click the mesh, and then go to the material tab, and then click the arrow, and then we want to rotate this thing again. So now we have a reference image, just like the slide we were seeing. Once that's done, now it's time to have CG sphere. So let's try to place a CG sphere in the UE4. I'm just going to make this our sample asset just a little bit down, and then bring the sphere in. So the way we do it, mode, sphere, drag and drop, make it center, and then just make it too close to where the reference image is. So we know the exact value that we can put it in. But one thing that I'm not really a fan of is that this default sphere is pretty low poly version. Let me quickly show it to you. If you go to wireframe mode, this is pretty low poly that we can see the faceting on the sphere. So I'm not really a big fan of it. So I'm just gonna use high poly version of the sphere in the engine. So static mesh tab, go to sphere, click the sphere, and then browse sphere. And then it will show all the sphere that we have in the engine. So high poly version sphere is called S_1 unit sphere high. So it's a high poly version. So you click it. this size is a little bit smaller than we want it. I'm gonna make it bigger, 50 times bigger, so it's gonna match, and then it's gonna be much higher poly that we can see smooth curvature of the sphere. So once that's done, we want it to have one more sphere. The trick that I just show you guys, press Alt key and click arrow button, drag and drop. And we want it to set it as -60. So now we have this reference image and the CG sphere. I'm just gonna save this screenshot, this angle. The way you do it is in the viewport. If you control and number button, it will save the viewport. So whenever you click the number again, it will snap back to the view where you are you were looking at. So once that is done, right now we don't have any material for this sphere. Sphere has just basic shape material. So let's create some material for the sphere. So I'm gonna make another folder called material and create master material called m_master material. Click again, this material editor again. So again, this material we wanted to create for the chrome ball and the gray ball. So I would like to make this as a master material, and then as an instance, I'm going to make a chrome ball and gray ball. So the way that we need it is that we need to parameterize whatever the input that we need to put it in for the gray and chrome ball sphere. So the way you can do is in the palette, you can search any input that you wanted to put it in. So we wanted to use base color and metallic and roughness for the gray and chrome ball. So you go to palette, you can search for any type that you wanted to make. So base color is vector, 3 vector with parameter. So if you type the vector parameter, there's a parameter ready. Also, it shows a shortcut on the one on the right, so which is V. So if you can drag and drop. Also, you can press B and click, and then it will create the same node. So once that node is created, you can rename it by this will be our base color, and then you link this node to the base color node. And for the metallic and roughness, metallic, like I said earlier, metallic is going to be 0 or 1, and the roughness is going to be how between the value 0 or 1 to decide how much rough is going to be. So for that value, we use the scalar. So the way you want it to do is a scalar value, and then there's a scalar parameter, which is the shortcut of S. So you can drag and drop, or you can press S key and click, and then you can have a parameter, scalar parameterized version. I'm just going to copy paste for now. And then you just input metallic one, and then the other one is roughness. And then let's name it as metallic, and then let's name this as roughness. Oops. Typo, roughness. And then once that's done, you can press apply to compile and save. So our master material is created. So let's make a material instance for the gray and chrome ball. So the way we do it is right click on the master material, and then you're going on the top. There's a create material instance menu. You click it, and you just name it MI as a material instance. And I'm gonna type it as a gray ball, and I'm going to duplicate this as MI chrome ball. So we do have 2 materials. So let's tweak this material as we want it. So this is material instance window. You go to bottom, there's a sphere ready. So let's change it to the sphere that we can preview better. Go to the detail detail window. So these 3 parameters we just created is available to change. So you just make sure to click that checkbox. So from the base color for the gray ball, as I say, we wanted to use a standard mid-gray. So we are on your engine is using the linear color space, which will be convert mid-gray to the 0.18. So we're just going to type the 0.18 and press OK. So this is going to be representing mid-gray in the engine. And metallic, gray ball is not metallic. This is has to be like a purely like diffuse ball. So we're just going to make it very rough as 1. So I'm just going to save. It looks good. And let's go to the another instance, which is chrome ball. Same thing. Click, check all the checkbox, and then for the chrome ball, let's use this color. This color will define the reflectance of the this chrome ball. For the start, we're just gonna use the value of the 1. Metallic chrome is metal, so we're just gonna put 1. And the roughness, we just might want to make a super shiny one, so we just not gonna put the value of the 0 for the roughness. Once that's done, you save, close. So now we created 2 material instances for the each chrome ball and the gray ball. Let's apply this each material to the our CG sphere we created. So you click the one sphere, click this material instance we just created, go to the detail window and go to the materials tab and click apply. So we now have CG version of the gray ball. Same thing to the chrome ball, click, go to the material and arrow. So now we have CG version of the sphere. Boom. But it's not the same as a reference image. So that is going to be the tweak that we have to do. Once again, let's go back to the slide. As you can see, this reference image and the CG version of the sphere is pretty much close to each other. So that will create a correct lighting environment. So let's starting to tweak this. So first of all, in the chrome ball, you see this black bottom. So the reason why the black bottom is happening is in the skylight, you click the skylight. Skylight has this option called the hemisphere. Lower hemisphere is solid color because when you think about the Earth, we are standing on the ground. So when the lighting is coming from the Earth, like from the top, it will bounce the floor and then it will just bounce back. So in the skylight, it will create like any color that you defined, and then it will act as a kind of floor that will decide your bouncing light. But for the sake of the look depth demo setting, I'm just gonna disable it. Once that's done, as you can see, this chrome ball doesn't have a black bottom anymore. Now what I wanted to do is to match this reference image to this chrome ball. So let's starting to change this rotation of the sky dome, which is this Earth that we created. Right now, what we see under this actual chrome ball is that reflection from the actual environment that is reflecting to the chrome sphere. So the way you tweak this scene is you can just simply click the sky dome and then starting to rotate around. But I know this HDRI image that we created, so this one is actually flipped. So I'm just gonna flip it to the image can be a correct direction, and then you just click the sky dome, and I'm just gonna rotate this thing. So also if you go to right top, there's this button for each, this one for the rotation, this one for the scale, this one for the position. This is a snap button. Any of the which is snap amount that you defined, it will snap to the desk value. But at this case, I just want to free rotate around, so I'm just gonna disable it. So disable, click the sky dome. So we do have this gizmo for the rotation gizmo for the sky dome. We're just gonna starting to rotate around. Okay, something like that, and then we get to close, and then still we don't see anything is changed. The skylight actually has been recaptured. So you click the skylight, and you go to the bottom, and then there's a capture button called recapture. Once it's recaptured, that means that skylight is just looking at the all the surrounding environment, and they're just like trying to make the cube map, the fixed side of the cube that has this texture information in it. So we just recreate it. So by looking at this image, reference image on the top and then bottom of the CG sphere, it looks pretty close. And then what I wanted to do is that match this sun position. So looking at this reference image, sun position is up to this fence and this box thing, and then CG sphere, sun position is way over. So the way you do it is that we're just gonna click sunlight here, and press G key. Will again is gonna show on hide the tool set indicator in the Unreal Engine. So I just press the G key to bring the direct sunlight icon back. So I'm just gonna bring it down. There I can see these three actors together, and then get close. So directional light, I'm just gonna starting to rotate around. As you can see, as I rotate this sunlight, actual sunlight position is changing. So I'm just gonna eyeball a little bit down, rotate. Oops. Okay, so I think by just rotating this ball, so now I think it's pretty close to the image in the slide and in our actual demo engine. So let's try to looking at this gray ball. So the trick that I was mentioned, so you just narrow your eyes a little bit, trying to make a blur filter on your eyes, and then looking at only shadow fall off, and then compare the reference image, and then bottom the CG sphere we created. So if you're looking at it, I think shadow fall off is pretty close. I think I'm happy with the way it is. So this is way to you set up the look depth scene. So once that look depth scene is created, we have to check all the setting is correctly done. So the way we do it is that one of the things that I mentioned earlier is the lighting ratio check. So we're gonna check how much the sunlight, how powerful the sunlight is, and how powerful the shadow light is, and then you compare the value, and then we can compare with the actual light meter checking value, which was a 4:1 value. So the way we do it is we use two plane meshes, apply the mid-gray material, and then place them to make it overlap a little bit, and then they can create a shadow. As you can see on here, it will create a shadow from the mesh 2 to the mesh 1. So we can measure mesh 1 this where my mouse cursor is, this sun value here, and the shadow value in the shadow. Also, the sunlight will be directly shoot the two plane mesh that we wanted to check. So let's go to the engine, and then let's just starting to create those two planes. So I'm just going to go back a little bit, and then you see the plane in the mode window, drag and drop, bring in here, make it center. I'm just going to bring it on the little bit of top. And then for the correctly checking, we wanted to make sure that plane is 90 degrees with the sunlight, that you get the direct light value correctly. So the way simply you can do is I'm just going to bring this sunlight, move close to this here. Sunlight doesn't get affected by position, as you guys know. So I can move around anywhere that I'm convenience to. So click the sunlight, and then if you're looking at the rotation, there are some values in there. You can just copy paste it, which you can do in the rotation. Where my mouse cursor is, right click, and then the copy paste menu will pop up, and then you copy, click, and you go to this plane, and then rotation, click, right click again, and then paste. And then now the sun and the plane is same direct angle, but we just wanted to angle it to plane to get the direct sunlight. So the way I'm gonna do it, I'm just gonna turn on this snap button for the rotation, and then make it click this button to make a gizmo local space, and then rotate 90 degrees. And now this plane is getting a light from the sunlight directly. Also, we wanted to use the mid-gray material. So actually, we already created a gray ball material that we can use as a mid-gray. So we just click material, gray ball material instance, and go to click the plane, and then go to the material tab, and click the arrow to apply it. Once that's done, we wanted to copy this plane to make another one to make overlap that can create the shadow. So the way we do it, press the Alt key and click drag and drop and just place it. And then you can starting to see the shadow that was created by this another mesh. So you just gently move. I'm just gonna move a little bit back that I can place in between. A little bit further. So now we have this plane that we can measure the value of it. So Unreal Engine has this feature. Let me make just a big screen, full screen, and then if you go to the show, visualize, and then there's HDR menu. So once you click it, watch your eyes, it's gonna be very green. Click. So now this is the HDR visualized view that you can see in the engine. I think our programmer who made this view has very good eyesight. I cannot even read that middle values. So I'm just gonna use the magnifier from the window to show the value. Much better, isn't it? But our programmer, I don't know where it came from. He must be from the Mongol. Mongolians supposed to have like good eyesight, right? But anyway, so from the top, L stands for the lighting value. RGB is red, green, blue channel. So right now, where where we're looking at it is gonna be the value, the pixel that is gonna be measured and then display the value we can check. So right now we are looking at the shadow, which is value of the 0.06. And let's move this screen slowly. Let me just get this thing. Oops. Okay, I'm just gonna go make camera speed a little bit slow. That I'm not gonna like pop too much. And then I just move to the position where the sun is hitting. And then I'm gonna bring back my magnifier, and then make it bigger. So the lighting value is 0.25. So shadow value was 0.06, and then multiply by 4 is 0.024. So slightly off, but then I think it's pretty close. Let me go back to remove this. Once again, this value checker is always helpful to make sure that if your value lighting is working correctly or not. So let's check with mid-gray color if it's correctly checked. So the way we can do is right now, what it displays, let me just quickly go back. So lighting asset that we have in the scene is, as you can see, sky dome, skylight, and directional light. So we have several different lighting sources coming from the affecting the scene right now. So this value that we were just checking is the combine of skylight and the sunlight. But when you wanted to measure this material correctly, you wanted to remove the skylight, which is indirect bounce light. So let me just go to the click the skylight and go to the detail menu. There's intensity, and then it's set to 1. Let me just disable it, set to 0. It will have right now we only have sunlight. So now let me going back to the show, visualize, and then HDR menu with a small list value. And then I'm gonna bring back my magnifier again. And so right now, where the blue is the actually shadow that we are looking at from the two plane. So shadow value, of course, is going to be 0 because there's no bounce light at the moment because we disabled the skylight. So let me move to this window, this cursor to where the sun is. Just a little bit more on the top. Yes. Okay, this right now we are pointing at where the plane is. The plane has a mid-gray value, so it's supposed to be lighting value should be 0.18, but it's not accurate. So that means that our sunlight is a little bit stronger than we expected. So this is good time to adjust the sun. So I'm just gonna bring this, go back to the scene, world outliner, click the sunlight, and then you can just starting to adjust this intensity value, and then this value will be changed. So we started with a value of pi, which is 3.14, but I think I'm just gonna lower it a little bit, which is 3, and then let me bring the magnifier for you guys. And lighting value is 0.18, so it's much closer to the mid-gray value now. So right now we can feel the sunlight is more correct for our scene. So let's go back again to bring the sunlight back. Sunlight detail window intensity set to 1, and going back to a little bit faster. Going back to check the shadow to sun ratio value. And I'm gonna bring back our magnifier to let you guys see better. So this is shadow value. So 0.06 still looking good. And I'm going to move this cursor to see the mid value better. So right now this pixel is 0.24, so which is much closer than before. So this is the way that you tweak little by little. So intensity of the sun to correctly matching. In the reality, it is really hard to capture actual intensity of the sun, but this is the kind of way that you can tweak for the sake of the looked at purpose. So once that's done, I'm happy with the way the lighting is set up. So we can starting to trust this scene. Let me quickly go to the next slide. So once the lighting setup is done, we can starting to check with the color checker to evaluate the scene with the white balance. So actually, all the image where we bring into the UE4 has to be color balance, white balanced with a color checker that you take a picture with. So this color checker is not really random color. They just put it in. It looks pretty, so they pick the color. It's not that is. That's not the reason. So actually, reason why is that this old value has a meaning, or kind of like sample of the color. So left top, this is representing kind of dark skin. One of the second one is like kind of light skin. This blue color is supposed to be like blue sky. Green is green foliage, and purple is purple flower is supposed to be. And then this mint color is just mint, and then this older color on the second and third row is representation of the what red value is supposed to be in the real world. So that this is good way to make sure that you have a physically plausible range in the color or not. They compare with the color checker with your material. Also, bottom line, this is just white to gray. If you measure this white, like I said, this is going to be pure white material in the world, which is fresh snow. So that you will convert it to the value of the 0.09. 0.9, and then if you go on the top, it's going to be the black will be most darkest black is charcoal, which is a 0.03. And then if you go to left, this should be the mid gray, which is the 0.18 or 0.19-ish. So let me go back to the engine, then we can create a color checker here. So I'm just going to go to reference image folder, right click again, import, and then there's a Macbeth color checker we created. So this macOS color checker is already color balanced in between process of the when you take a picture and then you have to process it and then you have to bring it to make it to the texture. You can bring it to the UE4. So this is process one. Again, you want it to make a material instance you can apply to the mesh. So I'm just gonna create a color checker material instance. Double click. Material instance window is popped up. We want it to have a color checker one. So click the color checker and then go to this parameter. Click and then you can have this texture displayed. Save, close, and I'm just gonna copy this one of the plane. Alt, drag and drop, and move it a little bit up. Also, I'm just gonna, okay, let me just put the camera speed back to 4 that I can move a little bit better. I'm just gonna move this up, that we can see this color checker better. So now we have a grayscale material apply this plane. We're just gonna click this mesh and click this material instance of the color checker, and then go to the material tab and press arrow. This aspect ratio is not correct. We're just gonna scale it a little bit. What the matter for the color checker is all about the color, so it's not really matter of the aspect ratio. So I'm just gonna scale it. So as you can see, this color checker is created you can reference. So again, you can use HDR view you can visualize and then evaluate if this color checker was correctly processed. So let me bring back our, magnifier. And the left bottom, as I said, this was a fresh snow, which is a pure white color in the world right now. So it is displaying as a 0.9, which is correct. I'm just gonna move a little bit slow. This is kind of hard. Okay, right now this is displaying all the way to the right, which is the black. So it is displaying the 0.03, which is the darkest darkest black in the world at the moment. So that you can compare this black and white to get the correct color balance. So all of this color checkers value is available on the web, so you can just search it. This is pretty standardized macOS color checker. So each color has a correct value that you can compare to make sure that your scene is correctly set up or not. So now we done. We have reference image, and then we have CG sphere. We place the sample mesh. We have color checker, and then we did check the lighting ratio value. So now I feel very satisfied with this look depth scene. So we can bring any asset to starting to tweak the material to have developing the look of the asset. So let me quickly show you guys some examples, samples. So I'm just gonna bring one of the asset that we were looking at in the beginning of our session. Bring the car, and then there's the other one. Bring it to the center. So once your scene is set up, you can bring your asset like this, and then you can starting to tweak to if the material is correct or not, what color this is supposed to be, etc. So actually what we did is that this environment looked at texture, we captured, we went to LA, and then we got collaborated with GM, and then we got actual car that has this exact color paint, a red color paint, and we place in that spot, and then we take a picture with a car, and then we compare that real photo to this UE4 engine view to compare one-to-one to match the look of the color or just the behavior of the material, if lighting is correctly reflecting in the surface or not. So right now, by looking at this, I think our bloom is kind of too wide. That looks kind of wrong to me because this is I know because like we already tweaked this car so many times. So if you remember sunlight, I was mentioned there's a mean roughness that you can tweak for the material. So once this will be decided, mean roughness effective for this light. So if you model value, it will go up. Let me just bring it to the up. And then you can see the reflection gets a little bit wider, and then bloom gets mushy. And then right now this looks like really matte. And then we can just bring it back. So 0.08 is a default value, but for this car, I would like to make this scene as 0.038, which will be make it reflection much sharper, and then the bloom size that we can happy with. So even for looking at this reference picture with this CG sphere, so we can see the reflection is a little bit close to the reference image. So that's how you do it. Also, like I said, actually Earth has a floor that you will get the bounce light. So you usually want to get any kind of floor for just representing the as a floor. So I'm going to bring it this mesh, plane mesh, just make it 30, something like that. And it's a good way to just apply this mid-gray material. You can this floor can acting as kind of floor that will create the shadow. So you can starting to see how the shadow will be created from this asset if this shadow is good enough, or if there any light leaking is happening. That all sort of way that you can starting to evaluate and tweak the scene. So I think I'm happy with this look, and this was the demo for the look dev today. I'm just going to go back to the slide. So let's go over quickly about all the setting again for the reference. So for the gray ball, can you guys see? For the gray ball, we use the 0.18 for the mid-gray color, but then we also take a picture to measure the exact number of the gray ball that we have if it's matched close to the mid-gray, which our ball was a little bit off, so we used a different value, but it is totally fine to use a mid-gray value, which is 0.18. For the chrome ball, you use the color of the one, metallic value of the one, which chrome is metal. So roughness, you want to make a super fine surface that can have a sharp reflection. So directional light intensity, you start with the 3.14, which is the pi value, and then you can start to tweak when you do the lighting ratio check, etc. And then for the temperature, you can use for the midday 5500 Kelvin is the kind of standard. For the skylight, you can use this cube map resolution, which is the 1024, and sky distance, sky distance threshold, which will decide how big that skylight will capture into the cube map. And then lower hemisphere is solid color. You disable it not to have black in the bottom. And post process is kind of long image. You're just trying to disable everything to make a scene neutral. So just disable everything, chromatic aberration, bloom, I like to set it, so I just leave it there. And then exposure, you set the min max brightness is 1:1, compensation as 0. Lens flare, disable it, image effect, vignetting, grain, and ambient occlusion, which is AO, motion blur, SSR. You just disable it, everything for the start of the look tab. And once that's done, you want to also make sure that infinite extend checkbox is on to apply all the post-process in the whole scene. So this was the one mesh setting that I was earlier talking about, the high precision and full precision UV. So in the setting mesh editor window, you can find under build setting, this huge high precision basis and huge precision UV, it will be, you can check it on. Just remember that whenever you use these high precision options, it's going to be cost a little bit more. So for the like really reflective material object that you want it to make, for example car surface, you want it to have a really sharp reflection, so that you want it to use a high precision. But for the like some matte, let's say like matte floor, you don't want it to have. We don't really see the like sharp reflection, so you don't really need the high precision tangent, which will be save the performance. Same goes to the high precision UVs. This is the project setting that you can just reference it. Oh, by the way, this all the slide is gonna be shared after the session, so that's why I put all the setting that you guys can reference it. So left side is console variable. You can add it in the config folder, default engine INI. So if you can type that in, it will apply these options. For the reference, I just put it in here. Look, I've seen this setting is recommended. So let's finish up our session today. So today we talk about the PBR, which is a physically based render material, a plausible range of the color, no specular for the no color information, a matter for matter or non-matter. Roughness, rough, matte, more rough it gets, it's going to be matte object, and then smooth it's going to be more shiny. We're also looking at the types of type and the mobility of the light. Also Azure as post-process, bloom, exposure, and a little bit of mesh, two mesh options. With took a look at it. And reference is very important. And then we talk about gray ball, chrome ball, high dynamic range of the panorama, and the color checker for the look depth scene, and why it's important, and we can use in the scene setup. And also we went over to the look depth setup. So again, sky dome, which is the earth, skylight, which is the bounce light, directional light, which is the sun, and then post-process any of the lens effect, and then check the lighting ratio to check if the lighting is set up correctly. So that's all for what I prepared today. I hopefully you guys find it helpful. Let's have a 20 like few minutes of the Q&A session. If you guys have any question, please.
I noticed you didn't mention. You didn't mention anything about the file format on the color checker that you imported. So I would assume it's linear, but I just want to make sure if other people aren't aware, probably not good to bring a JPEG in.
Yes. The question was that I didn't mention about any color format for the texture. So as you guys know, JPEG is highly compressed image that will be compressed a lot of data, and then you're not going to have a correct color information, and then color range is very small. So when we take a picture, we take a picture with a raw image that will have most data in the image set, and then we converted it to the TIFF or EXR that is like EXR is a 32-bit float value of the image that has most value that we wanted to have. So all the reference image that I imported in was the EXR, which is a 32-bit linear float value. So that has most range of the color that when you check the value from the visualized HDR view, you can see the value correctly. So thank you for bringing that up. Yeah. Anyone else? Yes.
Yeah, regarding the workflow, so you use these lab materials, these lab spheres, you took the photos,
right?
You're fairly confident about how those materials will translate into Unreal regarding the settings on the creation.
Right.
So the chrome and the rubber, the exact value of that gray. And it seems to me like after that, the whole tweaking is on the direct light until you get the matching ratio that you needed for the light and the shadow and the reflection matching and all that stuff. So it's mostly about tweaking that direct light until you get the matching of the values that you want, right?
Yes, correct.
Is that, let's say, because you were doing their measurements and they were fairly already around the neighborhood of what you needed it to be. But in this scenario in which they're fairly off to what you were looking at, what you were looking for, the next step will be to tweak that direct light until it matches what you're looking for. You won't go back and tweak the materials. You won't tweak the post-process volume. You will just tweak that direct light until it is what you're looking for, right?
Yes, that's correct. So question was that if something looks incorrect, do I want it to go back to tweak the direct light, which is a sunlight, to make sure that the scene is correct? So answer is yes. So the basic rule of the look depth, once you set up the look depth correctly, and then you check with the lighting ratio and then color checker, and then every setup, you make sure that it's correct, and then you go to the look depth setup that you can start to tweak your material. So once that stage that you don't want to touch anything in the look depth, but then when you're setting the look depth scene, of course you looking at the reference image of the gray and chrome board, and that's the data you want it to match. So until you match this gray CG sphere to the same as a reference image, you don't want it to move the stage to the next level. So you want that reference image of the gray and chrome board is the stage that where you make the look depth scene correctly. So that's, yeah, for the answer your question is correct. Yes, you just tweak the directional light for the make it sure that you get the same shadow follow from the gray board. Cool. Yes, anyone else?
So you're matching the directional light, and when you're rotating it, you're getting the angle by matching pretty much the bloom effect, right, to the photo. But shouldn't the photo already have that? Are you retouching the photo to get rid of that bloom?
No, bloom is already okay. Let me quickly go back to the. So if you're looking at the image, so you're talking about this bloom that is, the question is that if this bloom was processed during when I import it bring into the engine from the camera.
So you're matching the photo from the sphere, right? And you did an HDR panorama.
Yes.
In theory, that bloom should be in the panorama as well.
Yes, correct.
So you're retouching out that bloom from a panorama?
Well, so one of the process that you wanted to make sure that when you bring the reference image from camera to the engine is that you want it to minimize any contamination information that getting from the lens or camera. So if you're looking at the lens itself is creating there's like tons of lens exist in the world, and then all the lens has a different characteristic. So we wanted to reverse that to make sure that we don't get any that characteristic delivered into the engine, that if we bring that contamination information, the lighting scene will be incorrect. So that is correct that when we process the image, we wanted to make sure that we just reverse that, just get rid of the bloom, and then the color balance is correct, and then any of the lens characteristic is transferred or not. So we get rid of the vignetting or the grain of the camera. So for short answer, yes, we do process the image to make the most raw, neutral looking of the photo.
Thank you.
Thank you. Anyone else? Okay, I guess that's about it. So thank you so much for guys joining us.